Hey guys! Welcome back to the laboratory. In this video, we are looking at Newton's first law of motion. By the end of this video, you should be able to recall Newton's first law of motion, describe the effects of balanced and unbalanced forces, and explain what happens when an object reaches terminal velocity. So, let's go! The three laws of motion, devised by Sir Isaac Newton, are used to explain how forces affect the movement of objects. The first of these laws states that an object with balanced forces acting on it will stay at rest or at a constant velocity. In simpler terms, an object will continue to do whatever it's doing until it's acted upon by a non-zero or unbalanced force. For example, this ball is in motion and is being acted upon by an applied force of 15 newtons and a frictional force of 15 newtons. The forces acting on the ball are balanced and cancel one another. Therefore, the ball has a zero resultant force and will continue to move at a constant velocity. In other words, the speed and direction in which it's travelling will remain unchanged. According to Newton's first law, unless this ball were to experience an unbalanced force, it will continue to move at this exact speed in the same direction forever and ever and ever. Now, let's say this same ball was kicked. The size of the applied force would now be larger than the size of the frictional force. If the applied force increased to 30 newtons and the frictional force remained at 15, this would mean that the ball is now being acted upon by unbalanced forces. The resultant force on the ball would be 50 newtons to the right. The ball has now experienced a change in its motion because it's been acted upon by unbalanced forces. It's no longer travelling at a constant velocity, it's now accelerating to the right. The concept is the same when explaining why a stationary object remains stationary. If all of the forces acting on a stationary object remain balanced, then the object will remain at rest. It's not until this stationary object is acted upon by an unbalanced force, so in this case, if it were kicked, that it will experience a change in its motion. Newton's first law of motion can be used to explain why an object reaches its terminal velocity. That is, the point where an object free falling through a fluid, such as a gas or liquid, reaches its maximum speed. Let's use the idea of a skydiver jumping from an aircraft to explore this concept. As soon as the skydiver jumps, they immediately accelerate downwards due to their weight. At this initial stage, there is little air resistance acting on the skydiver because they are yet to pick up speed, so the resultant force downwards is large. As the skydiver picks up speed, the size of the air resistance acting on them increases. The weight of the skydiver is fixed and does not change, so the resultant force on the skydiver is smaller. They are still accelerating downwards, but not as quickly as they were at the start of the jump. Eventually, the skydiver reaches a speed at which they are travelling so fast that the air resistance acting on them is equal to their weight. The opposing forces acting on the skydiver are now balanced. The resultant force is zero, and the skydiver is now falling at a constant velocity. At this point, we say the skydiver has reached terminal velocity. The skydiver will now continue to fall at this velocity unless acted upon by an unbalanced force. For example, once they open their parachute, increasing the air resistance acting on them and thus slowing their descent. Here's an example of an exam-style question that I'd like for you to attempt to test your understanding of the content covered in this video. Pause the video and take your time to work it through. Press play once you're ready to check your answer. A student investigates terminal velocity. She uses a tall glass tube filled with oil and drops a metal ball into the tube. The ball falls through the oil. Use ideas about forces to explain how a falling object can reach terminal velocity. As discussed earlier in this video, terminal velocity is achieved when the opposing forces acting on a falling object become equal, therefore causing the object to move at a constant speed. The same is true for this scenario. Initially, the ball is going to accelerate downwards in the oil because of its weight, or you could have said the gravity acting on it. Naturally, drag is going to start acting on the ball, and the amount of drag will increase as the ball picks up speed. Eventually, the ball reaches a stage where its weight and the drag acting on it are equal. There is now a zero resultant force acting on the ball, and it has therefore reached its terminal velocity, where it will continue to move through the oil at a constant speed. So, how did you do on this question? Let me know in the comment section below. Anyway, that's it for this video, guys. Thank you for joining me in the laboratory. Please leave a like on this video if you found it useful, and don't forget to subscribe to the channel so that you don't miss another one. See you soon!